In this video, we will identify the SimCenter 3D files and describe how they are used in an analysis. The simplest CAE model consists of two files: the simulation file, .sim, which contains loads, constraints, and solver-specific data, as well as the FEM file, .fem, which contains meshes, physical properties, and material properties. The CAE model may also be associated to part files. The idealized part file contains geometry that you can modify for your analysis without modifying the original CAD geometry. And the master part file is the original CAD geometry. Now we're going to take a deeper look at what's contained in each of these files. The simulation file contains loads, constraints, and other boundary conditions. It includes solutions and solver-specific data that defines the solutions. It can be used to override the physical and material properties in the FEM file. You can use multiple simulation files to explore the effects of different physical properties, materials, thicknesses, etc. In the diagram on the right, you'll see that there are two simulation files defined. One has imported properties, and one has properties that override the FEM file's material properties and physical properties. You'll see that both are pointing to a single FEM file, which in turn points to an idealized part and a master part. Now let's look at the FEM file. The FEM file contains meshes, nodes, elements, physical properties, and material properties. It is the master model for the simulation file. There are two types of FEM files. The associative FEM file contains a pointer to a CAD part file, and it contains polygon geometry that is used for meshing. The non-associative FEM file is not associated with the CAD part file. It does not contain polygon geometry. It does contain nodes and elements, and it may contain imported mesh data. In the diagram on the right, you'll see that there are two FEM files that are associative FEM files. One points to an idealized part, which in turn points to the master part, and the other one just points directly to the master part. The third FEM file is non-associative. As you can see, it does not point to any part files. Now we'll look at the idealized part file. The idealized part file is a reference to the master part. It is used with associative FEM files. The CAD part file is a component of the idealized part file. Before you can modify geometry in the idealized part, you must promote or wave link bodies from the master part to the idealized part file. The idealized part file has a copy of the geometry that you can modify. The geometry in the master CAD part file does not change. The idealized part file enables you to explore what-if studies based on the same master part. In the diagram on the right, you'll see that we have a single master part, but four different idealized part files where you can explore the various changes to the geometry. The final file type is the master CAD part file, and this is the original CAD geometry. It is a component of the idealized part file. This completes our video, SimCenter 3D Files Overview.